Hello learners, in earlier lecture we have seen some basic things that we need for the selection of belt from the manufacturing catalog. Okay, that is flat belt. Okay, so for selection of flat belt from the manufacturing catalog, what we need four input parameters. Okay, we should know the four input parameters. Those are power to be transmitted, then input and output speed, then center distance and type of load. Okay, if we know those four input parameter, then we can select a belt from the manufacturing catalog. Okay, based on those four parameters, that is power to be transmitted, input and output speed, center distance and type of load. If those four parameters are known, then based on availability of those belts we can select a belt from the manufacturing catalog. Okay, now we know the power transmitter, power to be transmitted, that is rated power. We know the rated power. Now we need to modify that rated power, because there are factors which they have used in while they have used for finding a power rating will be different, and our situation, our power transmitting means when we are transmitting that power, those parameters are different. That means type of load which is acting over the belt over in our application will be different than the standard condition. Okay, then wrap angle will be different than the standard condition. For the standard condition they have taken 180-degree arc of contact. Okay, now in our case that arc of contact will be different, and based on that we have to modify the power to be transmitted. Okay, so those two factors we have to take into consideration for modifying the power, that is load correction factor and arc of contact factor that we have seen in last lecture. And third thing is what? Power transmitting capacity. Okay, generally in manufacturing catalog they provide a power rating. Okay, and the power rating will be given for what? 180-degree of arc of contact factor, 1 mm width of belt and single ply. Okay, for that condition they have given a power rating and with a belt velocity of 5.08 meter per second, but our velocity will be different than there, so that's why we need to modify the power rating. Okay, and we have to select a belt from the manufacturing catalog. For these things we will we'll see the different steps of procedure for selection of belt, and we are looking for Dunlop power transmission. Okay, Dunlop power transmission belt. Okay, there are two types of belt in Dunlop power transmission, that is high speed belt and Ford belt. Okay, high speed belt is used for the general application and Ford belt is for heavy duty application, that we will see. Okay, now first step in selection of belt is what? First we have to calculate the diameter of smaller and bigger pulley. Okay, for finding the diameter of smaller and bigger pulley, you know the formula, that is velocity is equals to what? Pi dn by 60. Okay, pi dn by 60. Now n is in rpm, velocity is in meter per second, and diameter that you will get in meters. So that's why what we did some modification over here. For finding a diameter of smaller pulley, d is equals to 60 into 1000 into v upon pi n. N is what? N is the speed, that is rpm of small pulley. Okay, now velocity is in meter per second. Now if we don't know the velocity, being a designer you have to decide a velocity. Okay, if you don't know the velocity, you can choose that velocity between an optimum range of belt. Okay, that optimum range is what? 17.8 meter per second to 22.9 meter per second if belt velocity is not given. Or being a designer you have to choose that what is the velocity of your application, what will the velocity of your belt. Okay, that you have to choose. Okay, based on that velocity you will find out the diameter of smaller pulley. Okay, when you get the diameter of smaller pulley, you have to find out a diameter of bigger pulley. So diameter of bigger pulley is what? Diameter of smaller pulley into input speed upon output speed. That will give you a diameter of bigger pulley. Now you will get a diameter of smaller pulley and bigger pulley. Now those are values that you need to modify, okay, to the nearest preferred diameter. In last lecture we have seen the preferred diameter of the pulley. Okay, so for that is those are the preferred diameter. Okay, so you will get value something like 115 suppose. So you have to select a next diameter pulley, that is 125. Okay, and that way you have to modify your diameter to the nearest preferred diameter. Okay, then based on those preferred diameter, because your diameters are changed now. Okay, so as your diameters are changed, you have to find out a correct belt velocity, because your assumed velocity will be different or your application velocity will be different. Okay, based on now preferred diameter, your velocity will be different. So you have to determine the correct belt velocity based on preferred diameter, and you have to see whether that velocity lies between the optimum velocity range or not. Your calculated velocity should be between optimum belt velocity range. So this is your first step, that is finding a diameter of smaller and bigger pulley. Okay, so next step is what? Next step is finding maximum power. Okay, as you know that power that is rated power generally is given to you, and based on your load which is acting over the belt, your power requirement will be different. So what you need to do, you have to modify that power. So your maximum power transmitting capacity is what? FA into power in kilowatt, rated power in kilowatt. So FA depends on your type of load or application for which your belt drive you are using. Okay, so FA you will calculate based on the type of load. Okay, so that will be given over here. Okay, so based on type of load you will select FA and you will calculate a maximum power. Okay, so this is your second step. Then next step is what? Next step, you have to modify your power. Okay, you have to correct your power based on what? Wrap angle. Okay, what will be the wrap angle of your belt over the smaller pulley? So you have to find out the wrap angle first. So wrap angle is 180. Wrap angle formula is this one, that is alpha s is equal to 180 minus 2 into sine inverse of d minus d upon 2c. C is the what? Center distance. Capital D is the diameter of bigger pulley. Small d is the diameter of diameter of smaller pulley, and based on that you will find out an wrap angle. And if your wrap angle is 180 degree, because you know that power rating is generally defined for 180 degree arc of contact. Okay, if your arc of wrap angle is 180 degree, then your FD will be 1 only. Okay, if it will be different, then you have to find out EFD based on your wrap angle, and you have to find out a corrected power. Corrected power is nothing but EFD into maximum power. Okay, so it will modify your corrected power, because your power, okay, power that you are transmitting, that depends on type of load and wrap angle. Okay, and power rating or powers are generally prescribed for what? Prescribed at 180 degree arc of contact. Okay, and for normal loading condition. Okay, there is no any shocks and vibrations or anything will be there. Okay, so those are prescribed for standard conditions. So we need to modify our power transmit or power requirement. Okay, then next step is what? Calculation of power rating. Why we need to calculate power rating? Because power rating is prescribed for 180 degree arc of contact. Okay, therefore single ply of 1 mm width and belt velocity of 5.08 meter per second. Now if your belt velocity will be different, generally optimum belt velocity is what? 17.8 meter per second to 22.9 meter per second. Okay, so you have selected a belt velocity within that range. So your velocity is different from the power rating for this power rating, which is prescribed at 5.08. Okay, so you have to calculate a corrected power rating by those formula for the high speed belting, because this power rating 0.0118 kilowatt is the power rating for the high speed belt of having a 1 mm width. Okay, and the arc of contact factor of 180 degree of single ply. Okay, so we need to modify it because its velocity will be different. Okay, so based on your velocity, power rating will be different. Okay, then you have to calculate a corrected power rating. The next step is what? Finding a width of ply basically. Okay, so basically width of ply into number of ply is nothing but corrected power upon corrected power rating. So we have already find out in fourth step corrected power we have find out, and in fifth step we have found out a corrected power rating. Okay, so if we get this ratio, we will get width into number of ply. Okay, now we get that product weight into number of ply. Now how many number of plies you are using and what will be the width of that ply, and that is our decision being a designer. So for finding the width of ply, what we'll do, we'll going for trial and error method. Okay, we are choosing a different number of plies for the corresponding width, finding corresponding width. Now we are getting the product of width into number of ply. Width into number of ply is equals to some value, some constant value, some number value there. Okay, so what we'll do, we'll assume some number of plies. Suppose we'll assume 3 number of plies, and we'll find out the width of ply. Then we'll assume a 4 number of plies, then we'll find out a width of ply. Then we will assume 5 number of ply, and we divide that constant with number of ply, and so that way we'll get a width of ply. Okay, so now width of ply we are getting for assumed number of ply. Okay, for assumed number of ply. So now based on number of plies and width in the standard chart, we'll select the width of ply. This is by trial and error method. And next step is what? Calculate the length of belt. So length of belt formula is this one, that is L is equal to 2c plus pi in bracket d plus d by 2 plus d minus d raised to 2 upon 4. So c is nothing but your center distance, capital is the diameter of bigger pulley, small is the diameter of smaller pulley. Okay, that will calculate the length of belt for the sixth belt, that is width of ply. Width of ply, for the width of ply, what we do? By trial and error method. As we have seen in an earlier lecture, width into number of ply is equal to some constant you are getting. Okay, so if you see over here, width into number of ply is equal to some constant. So we are assuming 3 ply. If we are assuming 3 ply, we divide that constant with 3 ply and we will get a width. Okay, so if our calculated width is closer, okay, means we are assuming a number of ply, and for which number of ply our width is closer to the standard width, that number of ply we are going to choose, and that width we are going to choose from the standard available catalog. Okay, so those are nothing but the procedure or steps for selecting a belt from the manufacturing catalog. Okay, in next lecture we will see some example based on these steps. Thank you.